All right, welcome everybody. We're going to go over Makefiles today. Makefiles are a way of making your build process go easier when you have lots of source code files. So you can see here in this directory, I've got 4 different source code files. I could do something like this, g++ start.cc, and compile all of them together. Hopefully it'll work, but it also takes a while, and it also doesn't work because I've got this file here that is actually like a dead file that I've been putting things in. So it's actually got duplicate code. So I can't just compile star.cc and expect it to work. A lot of times you can, but you also notice that noticeable lag of when you try compiling something that way. With a Makefile, you can just type make. And once you have your Makefile set up, which is what I'm going to go over today, it will go through all the steps of building your project for you. And you can see here, it has successfully compiled everything. It did not do anything with that dead file that I have there that's got some duplicate code in it because it's been configured properly. And the really cool thing about this is that if I edit something at this point, main.cc, let's say I come in here and I don't know, like fix a typo or something, like I'll change this 20 to 18 here. If I type make again, watch that it does not actually compile all these files again. The only file that changed was main.cc, and make knows that, and so it only recompiles, let me get my face out of the way, it only recompiles main.cc. So this makes it much, much faster to compile stuff when you have a large project. A lot of the projects I've worked on have had, I don't know, who knows how many, but like a, I don't know, standard medium-sized project might have 30 or 40 different files. You absolutely do not want to be recompiling everything every time. You know, you're going to end up having to take a coffee break every time you try compiling something. And one of the secrets to success in computer science is to be able to compile quickly, test quickly, see if your code is correct quickly, and then iterate quickly and move on. When your compile times get really long, then what happens is you start writing more and more code in between compiles because you want to get more work done. And then when you got like 100 lines of code that you haven't compiled or tested once, it's just, you know, it's disastrous. So if you were to edit, I don't know, rect.cc and change something here or something, I don't know. Again, you'll see that the Makefile detects that just rect.cc changed and only rect.cc gets recompiled, which is really nice. So again, you can see how quickly this process takes place. All it does is recompile with the -c flag. The -c flag, you can see it's 1 o'clock in the morning right now, that it generated this file called rect.o. This is a compiled version of rect.cc. And that's the secret to this whole thing, is that you can save sort of the intermediate compilation of each of these files into a .o file. And so rather than have to recompile everything every time, what you do is you save the .o files, these object files. And so if I were to edit, I don't know, point.cc and type make, you'll see that we do this -c point.cc. And you'll see here, point.cc just got edited at 1:15 in the morning, and you can see that point.o got updated as well. And that's really all Makefile does. It just looks to see which of your source files has been updated since the last time you compiled a.out, and those get recompiled. And then anything that depends upon them gets recompiled as well. So for example, there's one file in this whole thing that everybody depends on, and that is this header here called die.h, and it's just my standard die function that I always use for everything. This shouldn't change ever in a project, but if it did, I don't know. Let me just edit this timestamp on it. You'll see here the die.h now. No, let's just edit the timestamp on it. Touch, by the way, is a command that just makes it look like the file's been edited. So if I do touch die.h, it looks like I've edited the file and saved it. So if you come in here, you'll see that now die.h is after the timestamp of a.out. So if I make it now, because everything depends on it. Is my Makefile not set up right? It is not. It is not. Main.o depends on die.h. This is a great time to talk about the syntax of Makefiles. So the syntax of a Makefile is you have the thing that you're going to try to make. The ultimate product of this thing is a.out, and it depends upon main.o, rec.o, and point.o. Okay, well, how do I make main.o? Main.o relies upon these files. So if any of these files change, then I have to recompile main.o. And what you saw there was that I didn't have the dependency for die.h in the rule for building main.o. If you look at the source code for main.cc, you'll see up at the top here, it is in fact including die.h. Anything that you include should be a dependency in your Makefile. So if we come back in here, you'll see it's depending upon point.h, rec.h, ray.h, and die.h, which are point.h, rec.h, ray.h, and die.h. Okay, so my Makefile is now correct. This was done deliberately to show you how dependencies work in Makefiles. So now that everybody depends successfully upon die.h, when I make the thing, you will see that it is now recompiling everything because all of them use that one function. And so if I were to touch die.h again, you'll see it again rebuilds the entire project. And this is actually what I would consider a weakness of the header file life, which is that sometimes you have a header file that everybody depends upon, and if you're constantly like adding functions to it, you can trigger complete rebuilds over and over again and just really hose your compile time, when that's not necessarily what you have to have happen. You'd set up your projects in a lot of different ways. So let's look at the Makefile here. So Makefiles, there's a lot to Makefiles. There's books on how to write Makefiles. It's a weird syntax, unique all to itself. But basically what it's doing is it's creating a graph or a dependency web of what things depend upon what things. So this guy here, a.out, depends upon these guys. If any of these guys change, it's going to rebuild a.out. What command does it do to rebuild a.out? It runs this command right here. Okay, well, what is *cc? It is G++. If I want to change my compiler for the entire project, I could come up here and I could edit this to be clean++. And I should probably do a make clean. Anytime you do something major like that, you should erase all of your .o files. You see that make clean deletes a.out. It deletes all of the .o files. And this means that when I do make, it will rebuild everything from scratch. Okay, that's fair. And you can see it's now rebuilt using a completely different compiler. I didn't have to do 900 different steps. I didn't have to compile each file by hand. I can just change one variable right there, and the compilers change for everybody. Just the one thing you want to do is do a make clean. It's a really bad idea to change your compiler so that half your .o files are built with G++, half are built with Clang. It might work, but very probably not. And then this variable here, cc flags, contains all of the compile flags that I use. I'm compiling with C++17. I'm turning on all warnings, and then even more warnings than all warnings, because all warnings is not, in fact, all warnings. It's poorly named. I'm turning debugging on. I'm turning the optimizer on full power, and I'm turning off a couple of warnings that irk me when I'm doing development. And so that's why you see Clang++ with all these flags. Main.o, rec.o, point.o, that's what builds a.out. This is actually called the link step. And the link step takes all the .o files and puts them together and builds an executable from it. All of these .o files rely upon a different set of other files. So point.o relies upon these four. And how do we get from these files to this thing? Well, that's the command right there. And so what you have here is a dependency graph, okay? And the way it's set up, and you can actually kind of extract this from your header includes, right? Like if you look at what files you're including, that's who you depend upon. So if main includes ray.h, then if ray.h changes, I need to change as main as well. If I look at ray.cc, there is no ray.cc. If I look at rect.cc, rec.cc depends upon rec.h. Okay. What does rec.h depend on? Depends upon point.h. Okay. What does point.h depend on? It depends upon die.h. Okay. Now you might notice that in rec.h I have both die.h and point.h, which means that die.h is getting double included. And this is bad. Okay. Except we've handled it. So if I look at die.h, at the very top here, I've got something called a header guard. And I don't know why the syntax highlighting is not working on it, but you will see this in pretty much every header file. Every time you do a header file like this, you will see one of two different ways of doing header guards. This is the first way. If not defined die_h, then define die_h. So the first time you include it, it's not defined, so it puts this code into your thing. The second time you do it, it's been defined, and so it just skips over the whole thing. So if you double include, triple include, quadruple include die.h, none of the extra includes will do anything. So here, point.h is including die.h, and I'm including die.h. So the include inside of point.h is actually not going to do anything. If I take that out, nothing breaks. Because why? Because point.h is including die.h, so I'm getting it anyway, and none of my code is going to explode as a result. Now this thing here is the other way of doing a header guard. Anytime you have a header file, you should always, always, always have header guards, just in case you include the header file twice. Because like we've seen here, like rect is including point, and point is including die, and rect might include die, and ray might include rect and point, but rect includes point. You never want your code to explode if it gets included twice by accident. This is the other way of doing it, which is hashtag pragma once, pound pragma once. And you notice at the bottom here, there's no end of the header guard like we had with die.h. So if I save that, see here, there's 3 lines of code. You have to do an if and def, a define, and at the very bottom, you have to have the end if. A lot of people forget that, and then all hell breaks loose when you include things. So yeah, it'll give you a warning or an error. But like if you give the wrong name here, then things will break. So the traditional way of doing header guards is standard, but this is not standard. Hashtag pragma once is not the standard way of doing it. It's not in the standard at all, but every compiler supports it. And so I've sort of moved all of my code to using pound pragma once, because then you don't have, if you copy and paste, you don't accidentally have the names mismatched. You don't forget, you don't have to remember to put the thing at the bottom of the file. It's just 1 line instead of 3. The downside to hashtag pragma once is that this relies upon, what this means, by the way, is that it's relying upon the compiler to not allow it to be included more than 1 time. And so with the header guards, the traditional header guards, the compiler has a list of all the things that have been defined, and so it can just check, oh, I've seen die.h before, don't do it. But if you ever copy and paste 2 different files, you don't change the header guard on it, you screw yourself up. And so the question is, what's your threat model? If you're worried about your compiler not being able to figure out this is the same file twice, which happens if you're on like a network file share, if you have shortcuts, sometimes the compiler cannot figure out that you've included this file already. If you include it one way and you include it a different way through a shortcut, pragma once can break. If that's a threat model to you, use traditional header guards. For me, I've been burned by traditional header guards a lot more than I've been burned by hashtag pragma once. Like I said, I might copy die.h to be like die2.h. I'm making a new one. And then I might just leave this here. And then if you include die2 and die1, well, die.h is already defined. It doesn't get included. My code doesn't appear. I start ripping my hair out. It's a thing that happens. And that is, and I might not change it because like I might be intending to move the file die2.h onto die.h once I've updated it. Yeah, if you rename the file, then you have to rename your header guard. It really depends just what you're worried about. Personally, I've never been burned by this. But then again, my build, I don't use like shortcuts and aliases and network mounts that could screw things up. If you do, you should probably use the other method. I have found pound pragma once to be the best for me, at least. Okay, so going back to the formatting here, there's a tab here. I should have mentioned that earlier. That is a tab character. So basically, the rule for a Makefile rule is you have the target, colon, dependencies, and then a tab, and then how to do it. So a dot, echo hi. You can run any command you want here. G++, star.cc, whatever you want. That's the basic format of a Makefile. This is the thing being built, colon, the list of everything that it depends upon, then how to go from main.cc to main.o, just like that. All right. There are much more complicated Makefiles. This Makefile here will just simply compile all of your .cc files in the current directory. It works as long as you don't have something like, well, this thing here. I've got this intersect.cc that's got the same function name as something as in main, because I've been thinking about moving this out of main and into a different file. And so if I just ran that big mega Makefile that I just showed you a second ago, it just compiles all the .cc files together, and then I would get explosions. So if you have two different files that both have main in it, for example, it's quite common for me to have a main project, and then I might have little helper files that are little tools that generate things, and they have their own mains in them. You can't use this Makefile here with that. You have to keep every main gets its own folder, essentially. And so just everything in the folder is for that one build. And so if that's how you like organizing your files, this is a fantastic way of doing a Makefile. It just simplifies everything. You don't have to, like, if you look at the one in here, this is kind of annoying, right? This is kind of annoying. Every time you have a new dependency, you have to like come into the Makefile and be like, oh, right, I forgot, like I did a second ago, I forgot that main relies upon die.h. You have to add that dependency yourself. And as you include things and not, it becomes annoying to track, because the dependency graph, if I want to draw this here, is main includes ray, main includes die, main includes rect, and main includes point. And then ray includes point, and point includes die, and rect includes point, and rect was including die as well. And so you have these, like, and this is just for a fairly small project, right? This is like not like a complicated project at all. When you've got 40 source code files, 50 source code files, and people are including each other all over the place, like, my Lord, like, it gets complicated. And so tracking that inside of your Makefile, each file and the list of all the things it's including, oh man, it gets to be a nightmare. And so in those circumstances, this one is preferable because it just figures everything out automatically. So, the downside is headers that are so .cc file, the only header that .cc file depends upon is the header with the same name. So if you have a point.cc, it only depends upon point.h. And so you can run into situations where this doesn't actually generate the proper dependencies when you have transitive dependencies and things like that. So this one itself is also limited. There are tools that could generate essentially dependencies for you, and we can probably do a lecture another time on CMake. But for like basic projects where like everybody just has a .cc file and a .h file, like inside of here, if you want to look at this, we have rect.h, which describes a rectangle, and we have point.h, which describes a point. A point is just an xy coordinate and some functions associated with it. The .cc file associated with it has the actual code for it. This is a very common way of dividing up. Like, what do you put in your .h file? What do you put in your .cc file? It's actually a more complicated question than you might think. But a fairly standard way of doing it is the .h file has everything you need to know as far as like member variables go, and then just a list of all the functions. with semicolon. So you've declared that a function exists. There is a function named distance to another point that'll tell me how far it is away using Pythagorean theorem and stuff like that. And that's it. And so when people are using your code, this header file is actually a really nice reference, because all they really need to use your code, like when I was writing main a second ago, I would just pull up the .h file. Like, oh, what was the name of the, I couldn't remember the name of the function to see if a point was inside of a rectangle. And so I just pull up the rectangle header file. And if you had a ton of code in there, you kind of have to scroll around a little bit. But with this, it's just like, oh, there it is in, returns true if a point's in a rectangle, boom. It's just like a little handy self-documenting, bit of code. And then the actual code for could be found on the .h file and the .cc file. And so it is right here. And so it just says if the point is greater than or equal to the minimum and less than or equal to the maximum in both the x and the y directions, it's true. It's within the rectangle. And so you can kind of put a lot of the stuff that causes people to go cross-eyed and scared. You put all that stuff like into the .cc file, because usually all people need to know to use your class is just what is the name of the function and what does it do. Here are my getters. Here's my copy constructor. Now here I have a little bit of code in the .h file, and that's fine. You can actually leave code in the .h file. There's no like for getters and things like that. Like it's pretty common for me to just leave it in there because it's so small. It's just like return min. Like it's more typing to like copy and paste, point, get min, and put it into a different file than it is to just say, like right here, it's pretty common for me to just be like, like return min, like that's, to me, like simpler. It's kind of one of those things. And so here I actually have the constructor, the code for it in the .h file. And then the last thing I want to show you guys is how do you split a class, and this is it on Makefiles, but I'll show you how to edit the Makefile in a second for this. So I've got this Ray class, and it's got code in it, and it's pretty common for me to start off by writing my classes as what's called header only. So there is no ray.cc right now. There's only a ray.h. There's all the code for my Ray class is right here inside of a .h file. But what happens is that after the class starts getting really big, your compile times will start slowing down, especially if lots of people are including ray.h. It's a lot better to just squeeze it down to size, put all the code into a .cc file, and then you can speed up your compilation times as a result. So I'm going to show you that process right now. We're going to say, okay, we're getting annoyed at how big this header is. It's not actually that big. It's like 37 lines of code, whatever. It's not like this is actually fine, but I want to go through the process. You can kind of see how I go about splitting a .h file into a .cc file. So I'm going to copy ray.h to ray.cc, and I'm going to vim ray.h, and I'm going to take out all of the code. Now this code here is an empty function. I can just leave that. That's fine. I'm going to do a $, semicolon. And what that's going to do, it's going to erase the function body and replace it with a semicolon. And then for the friend functions, I'm going to erase the body of them as well. And there we go. So now we have a squeezed down header file. The only code I have in here is the constructor because, well, that's a pretty small function. It's an empty function, so I don't see any point putting this in the .cc file. Yeah, technically these things are unnecessary because they're here as well, but whatever. Okay. Oh, one other thing. Do I need string here? Don't think I do. And I don't think I need IOmanip here anymore, or CMath. So one thing you should always check for is once you've squeezed it down to kind of cut down on the number of includes you have, because when anybody includes Ray, they're going to include all those headers as well. And so if you have a lot of different people including Ray, then all of them get all of those includes as well, copying and pasting tons of code into their code that they're not going to use. So it's always a good idea to just sort of take a moment and be like, the only thing I need in here is IOStream, and I believe that's being included transitively from point.h, because everything you include in point.h gets included in point.h includes die.h. If you look at die.h, die.h includes IOStream. So, or if that seems a little bit dubious to you, like, well, how am I supposed to know it's included 3 levels up? Just put the include in there. Remember, because the header guards, if you try including IOStream when it's already included, it won't do anything. So, you're fine. Then we come into ray.cc, and all we need in ray.cc is to include ray.h. Basically, every .cc file should include its name, but .h instead. Class ray, we get rid of that, get rid of all this stuff, get rid of the constructor. Left arrow, shift G, all these comments. That doesn't need to be friend anymore. Get rid of the class, semicolon. And then any of the member functions. Friend functions, remember, are not member functions. They're technically like global functions that are just given private member access. So all you have to do with them is pop the friend off the front, you're good. And then for this one, I'm going to say ray : dot. And now we have converted a header-only .h file into a split .h and .cc file. And skimming this over real fast. We are not using include namespace, using namespace standard. We could feasibly put it back in here if we wanted. When you have a header file, which it was before, like 10 seconds ago, ray.h was a header file. And when you have that, it's a really bad practice to put using namespace standard in a header file, because anybody that includes your header file now gets std imported into their namespace. And if they have some conflict, it's going to explode their code, and they're going to get mad at you. In a .cc file, knock yourself out. It doesn't matter. However, I'm not going to take the time and effort to refactor my code to delete all these stds. So I'm just going to leave it. It's fine. It's a-okay. So now we've got to add a new rule to the Makefile. So really anywhere within here is fine. I'm going to have ray.o. Remember, when you compile a .cc file, you partially compile it. It goes from ray.cc to ray.o. And so ray.o is going to depend upon ray.cc. Ray.cc depends upon ray.h. Ray.h depends upon point.h, and point.h depends upon die.h. See what I mean about the dependencies being annoying? They are. And then the actual compilation line here, remember that's a tab there. Makefiles require you to have a tab there. I don't know why, but you do. And so we're going to clang ++, and ray.cc. And I'm now going to make my code and use an undeclared identifier, nan const. So what happened here? Oh, main.cc. There we go. So main, see, this is, again, kind of what I was pointing about earlier. When you have a transitive include, like I was including ray.h, and ray.h was including cmath, that was my source of cmath. And so when I pulled that out of ray.h, as I should have, now main.cc did not have cmath included, and I had to add it back in. So that everything is good now. All right. That's why I said it's not always a good idea to clean. Let's see if we can fix this. It's not always a good idea to oh, I know what it is. Rely upon those transitive includes. I forgot to add it here as well. Okay. So ray.o, and this is ray.o as well. So we're compiling main, rect, getting a warning there. Pragma once in main file. Aha, yeah. Let's get rid of that. That was a copy paste error for sure. And then everything works. So let's see if array can hit a rectangle. So if we are at 0, 0 with a slope of 1, we're shooting array up this way, and we've got a rectangle at 4, 4 to 10, 19, 19, sure, whatever. Then the ray hits the bottom left corner, and all is right in the world. So that's about it for Makefiles. So we went over today how to make a Makefile, how to split a class and add the rules for that into your Makefile. I will show you one last time the Makefile that I use in a lot of projects. What this means is find all .h files, all .cc files. Oh, I'm sorry. I think I said that wrong. Yeah, every .cc file now relies upon every .h file. So changing any .h file will trigger a full recompile. This is not great, but it's simple, at least to handle the Makefiling. It is compiling with optimization disabled, debugging on, C++ 20 standard. And basically it's just, this is a Makefile that's really good if you have a simple project where you got like 10.cc files, some header files, and then it'll just build it all together. And if you change a .cc file, it'll recompile that one CC file and link it all together, and you're good. The only trouble is, like I said, if you edit a .h file, then everything recompiles. You could fix it and make it the way that I said it, which I've done before, by doing something like this, where you can do a wildcard pattern match and swap the .cc with the .o. You do the same for .h file, and then make each person rely upon just their .h file. But actually generating a dependency graph is beyond the scope of this talk. So that is basically how Makefiles work. And if you try making something that's already built, it doesn't do anything. It's great. So make is your friend, make is life. It looks a little bit foreign, but after you get used to it, it's just honestly not a big deal. Once you start getting into like cross-platform and things like that, there's package management, stuff like that. Like it definitely gets a little bit more complicated. And there's tools like CMake and Mason and things like that to handle that. That's it for now. All right. It is 1:40 in the morning. I'm signing off.